Direct air capture enters Dutch greenhouse CO₂ supply chains. Skytree and Lingezegen Energy are bringing direct air capture into a practical commercial setting with the first commercial deployment of the Skytree Stratus system in the Netherlands. The project will supply fossil-free carbon dioxide to a greenhouse cluster served by Lingezegen Energy, a regional Dutch energy company. For growers, the focus is not only emissions reduction, it is also about securing a reliable CO₂ supply at a time when traditional industrial sources are becoming more exposed to price pressure, supply risk, and decarbonization policy. Greenhouse operators use CO₂ enrichment to support crop growth, yield, and quality. Historically, much of that CO₂ has been linked to industrial processes or fossil fuel use. As those sources change or decline, horticulture businesses face a more practical question: where will stable, affordable, and lower carbon CO₂ come from? The Skytree Stratus system is scheduled for deployment in 2026 with an initial capture capacity of 900 metric tons of atmospheric CO₂ per year. In 2027, the project is expected to scale to 7,200 metric tons annually, supplying 10 greenhouses across around 80 hectares. The system will be integrated with Lingezegen Energy's existing renewable infrastructure, which includes a floating solar park and thermal storage. That local integration is central to the project. Instead of transporting CO₂ from distant industrial sources, the model is designed to produce carbon dioxide close to where growers need it. For the Dutch horticulture sector, this marks an early test of whether direct air capture can shift from climate technology concept to operational infrastructure. The business case will depend on reliability, cost, energy performance, and how well the system fits into daily greenhouse operations. What the Stratus deployment needs to prove. Skytree is positioning Stratus for customers that rely on CO₂ but face rising liquid CO₂ prices, supply disruption, or pressure to reduce fossil-linked inputs. The company says the platform is supported by more than 2 years of operational lab data and is now moving into commercial use. The Netherlands project is also a milestone for Skytree's own development. It signals a move from research, testing, and field validation toward manufacturing industrial direct air capture systems for real-world customers. Direct air capture still faces familiar questions. Energy demand, cost, and scalability remain key issues for any company trying to use atmospheric CO₂ commercially. Skytree says its Stratus system uses moving bed technology that separates adsorption and desorption. In simple terms, the material that captures CO₂ moves between cold and hot chambers rather than heating the entire machine during the release process. According to Skytree, the system can use low-grade heat of at least 80 degrees Celsius for most of its heating load. Depending on configuration, electricity consumption can fall to around 0.9 to 1.0 megawatt-hours per metric ton of CO₂ captured. The company links this performance to an approach that heats the capture material itself rather than the full surrounding system. Stratus is modular, with individual unit capacity starting at 2.5 metric tons of CO₂ per day. The format is designed to support scaling into larger direct air capture parks, while making maintenance and future upgrades more manageable. Skytree also uses process control software to monitor ambient conditions and help maintain steadier CO₂ output through seasonal temperature changes. The first commercial use case is greenhouse production, but the potential market is wider. Other sectors that need reliable CO₂ include e-fuels, food and beverage, packaging, and industrial users looking for more localized carbon supply. For growers, the real value will not come from the technology label. It will come from whether the system can deliver dependable CO₂ at a workable cost with lower exposure to fossil-linked supply chains. If the Lingezegen Energy project performs as planned, it could give the horticulture sector an early commercial model for decentralized, fossil-free CO₂ supply.